Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning all about Grote Reber, an American scientist who built the first radio telescope in his mom's backyard. I know he may not be a household name, but part of the point of this show is to learn more about amazing people, places, and things that are often overlooked. And I recently found out that Reber built his giant homemade telescope just a few blocks from where I grew up, and I knew nothing about it. But trust me, after doing a bit of research, his story is amazing. Now, as always, before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. In 1937, when Reber built his radio telescope, people really didn't know what to think of the giant steel and wood dish in the yard of a suburban home. Neighbors grew concerned, and rumors spread around town that Reber could be using his dish to contact Mars. Some say the fear and speculation got so out of control, local newspapers had to run articles reassuring the public that Reber was running a safe, legitimate experiment. What do you think? Did a backyard telescope cause a small suburban panic? We'll find out at the end of the episode. Now for your word of the day. Our word for today is parabolic. That's Parabolic. Parabolic is an adjective describing something that has the shape of a parabola, which is a symmetrical, open curve formed by the intersection of a cone with a plane parallel to its side. In physics and engineering, a parabolic reflector is a curved surface that reflects incoming parallel waves like light, sound, or radio signals to a single spot called the focal point. And it also actually works in reverse. If you put a source of energy like a light at the focal point and send it out to the parabolic reflector, it will produce a parallel beam going out. This is why parabolic reflectors are essential for designing satellite dishes, car headlights, searchlights, and reflecting telescopes. The word parabolic comes from the ancient Greek word parabole, which combines para, meaning alongside or beside, and balein, meaning to throw. Originally, the term referred to placing things side by side for comparison or application, kind of like a juxtaposition. Mathematicians adopted the term around 200 BCE. When Grote Reber designed his telescope in the 1930s, he chose a parabolic shape because, unlike conventional curved lenses, a parabolic reflector focuses all wavelengths of electromagnetic radiation to the exact same focal point without distortion. Time for your daily high five, our top 5 fun facts about Grote Reber. Number 1. Grote Reber spent $1,300 of his own money to build a 31-foot parabolic antenna in his mom's yard. In 1937, professional astronomical observatories turned down his requests to study cosmic radio waves due to a lack of funding because, it was the Great Depression. Reber decided to fund and construct the massive telescope by himself, and he did it in his mom's side yard in Wheaton, Illinois. It cost him about $1,300, which would be quite a bit of money to spend on a telescope even today, but back then, this was a lot of money. It was about half an average American family's annual income. Adjusted for inflation, it would be the equivalent of about $30,000 today, so it was a substantial investment for him to make. Reber worked full-time as a radio engineer in Chicago while pursuing his passion for astronomy at night. Even with that relatively large budget, he still had to keep his construction costs as low as he could. So he built it using some sheet metal, wooden rafters, and spare parts from a Ford Model T. He made a 31-foot metal dish supported by wooden rafters and mounted on a custom frame. The focal point of the dish stood 20 feet above the center, where a specialized receiver amplified faint radio signals. He spent months adjusting the alignment to make sure the curve reflected incoming high frequency radio waves accurately. But all that time, effort, and money paid off. It laid the foundation for all modern dish-shaped radio telescopes used around the world. And today, his original groundbreaking radio telescope from 1937 has been fully restored, and it's recognized as a National Historic Landmark on display at the Green Bank Observatory in West Virginia. Number 2. Reber had to do his radio astronomy experiments after midnight to avoid interference from passing cars. When Reber began collecting data from the sky, he quickly ran into a major technical obstacle caused by local traffic. The electrical sparks in the spark plugs from engines would overwhelm his sensitive radio receivers. The faint signals coming from deep space were essentially masked by the electromagnetic noise generated by nearby cars and trucks. Reber had to adjust his sleep schedule so he could operate the dish late at night when there really wasn't any traffic. From midnight until 6 a.m., he would sit in his basement recording receiver measurements on paper charts while monitoring the telescope. Then he would sleep for a few hours before going to his day job at a radio manufacturing plant in Chicago. The routine was no doubt exhausting, but he kept it up for several years, gathering data across multiple radio frequency bands. Number 3. Reber discovered invisible radiation sources like Cygnus A and Cassiopeia A. Between 1938 and 1943, Reber systematically scanned the northern sky to measure radio waves emitted by celestial objects. He compiled his measurement points into contour maps that displayed the sky based on radio brightness rather than visible light. These maps showed that the strongest radio emissions originated from the central plane of the Milky Way galaxy. His charts also showed concentrated radio sources that had no bright visible light in the constellations of Cygnus and Cassiopeia. Scientists later identified these mysterious objects as distant active galaxies and ancient supernova remnants emitting powerful energy streams. Reber published his groundbreaking sky maps in the Astrophysical Journal in 1944 after initial skepticism from mainstream astronomers. These early maps served as the primary reference guide for researchers when radio astronomy expanded after World War II. Number 4. Reber discovered that cosmic radio waves didn't follow the standard thermal radiation laws predicted by physics. Standard physics theories predicted that stars and hot celestial bodies would give off radio waves through thermal radiation, basically heat. Under thermal radiation rules, more energy means higher frequencies and shorter wavelengths. But when Reber tested receivers at high frequencies, he didn't detect any signals from space. It was only when he built a receiver for lower frequencies that the signals finally became clear and readable. His measurements showed that cosmic radio energy was actually stronger at lower frequencies than at higher ones. This was unexpected. It was basically the inverse of the expectations. It proved that the non-thermal energy process was generating the signals. Physicists later figured out that the radiation was synchrotronic emission caused by high-speed electrons spiraling around magnetic fields. Reber's data provided the first observational evidence of this energetic process occurring on literally a galactic scale. And our fifth and final fun fact for today, Reber moved to Tasmania to study ultra-low frequency radio waves that can't pass through most of Earth's atmosphere. In the 1950s, as mainstream radio astronomy shifted toward high frequencies, Reber decided to go low. he explored low frequencies below 2 megahertz. Earth's ionosphere reflects most long wavelength radio waves, preventing them from reaching ground level telescopes. But during periods of low solar activity, atmospheric conditions near Earth's polar regions occasionally have an open window for these longer radio waves to reach the ground. Reber moved to Bothwell, Tasmania, where he designed and constructed custom antenna arrays spread across farm fields. Operating at wavelengths up to 144 meters, he successfully mapped cosmic low-frequency radio emissions that no other team could detect. He continued his research in Tasmania for decades, living in an energy-efficient home he designed himself. Now for some news you can use. If you work with sensitive audio equipment, radios, or electronic hobby projects at home, you can reduce unwanted electromagnetic interference with some of the same principles that Grote Reber used. Electrical devices like routers, computer chargers, fluorescent lights, and appliance motors generate high-frequency electromagnetic noise that travels through power lines and through the air. You can eliminate a lot of this interference by plugging sensitive equipment into grounded power strips with built-in EMI filters, keeping signal cables separated from main power cords, and clamping ferrite chokes around your audio or data cables. A ferrite choke is a magnetic ring or cylinder placed around a cable to block high-frequency electronic noise, prevent signal interference, and stop cords from acting as antennas. They absorb high-frequency electromagnetic noise and convert it into tiny amounts of heat before it can reach your receiver or recording device. Separating audio or antenna lines from AC power cords prevents inductive coupling, where electrical current in one wire leaks magnetic signals into wires that are next to it. Applying these isolation steps cleans up background hums and static, so you get crisp, clear signals in your microphones, home audio setups, and radio receivers. Finally, the moment you've been waiting for. At the beginning of the episode, I asked if Grote Reber's radio telescope caused wild rumors and concern that he might be contacting Mars. Oddly enough, that's a fact. When Reber constructed the 31-foot steel and wood dish in his mom's side yard, the people of Wheaton had never seen anything like it. I mean, think about it. Radio astronomy literally did not exist before then. He built the first radio telescope. So people couldn't imagine a practical reason for a giant parabolic metal dish aimed at the sky. Rumors quickly circulated through the neighborhood that the massive machine was an alien communication array, a secret military weapon, or some sort of experimental weather control device. Local newspapers stepped in to address the growing public curiosity and unease. An article from May 7th, 1938, ran with the headline, "No Wild Scheme from Mars, but Planned Scientific Experiment." Newspapers like the Chicago Tribune sent reporters and photographers out to interview Reber. Their articles explained the underlying physics of electromagnetic waves, highlighted Reber's credentials as an engineer, and assured readers that the dish was a passive receiver collecting cosmic rays rather than an active transmitter signaling outer space. Now, I hope you enjoyed learning a bit about Grote Reber with me today. And if you have someone or something awesome from your hometown that you think would make a great subject for a future episode, feel free to email me at funfactsdailypod@gmail.com. And as always, be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.